Hi, check it out. We've got a completely Australian designed and manufactured USB oscilloscope. This is from Liquid Instruments. Thank you very much, Liquid Instruments, for sending this in. I've actually done a video on this on my second channel at the electronics show last year, where I talked to them about this on the trade show stand, and they said they'd send me one, and they have. This is the bottom of the range unit, the Moku Go. This is 599 Yankee bucks, or close to like 1,000 Aussie bucks here. It's a dual channel 30 megahertz USB oscilloscope, but it's mixed signal. It's dual channel 20 megahertz output as well, function gen. It's got mixed signal digital. It's got networking with their other high-end products, and I'll put up the sheet here. Their other products, they go from this little unit right up to, well, if you have to ask the price, you can't afford it, but they all network together. And apparently there's 14 instruments in one here, because with USB oscilloscopes, it's all about the software. Anyway, let's have a squiz here. There's the little beastie. Look at that. That looks good. Australian designed and manufactured. Right off the bat here, I'm going to complain. They've got the in and out molded in here. Very hard to read. It's not like in a different color or anything like that, but because it's molded into the front plate. Just a small thing, but anyway, yeah, so dual 30 megahertz input, 125 meg samples per second, 12-bit. We've got dual 20 megahertz analog bandwidth out. We've got a USB-C. There's our mixed signal digital stuff. We've got the Ethernet, and it's got four programmable power supplies. No digital multimeter built in, but anyway, what is that? That's oddball. What's going on there? Liquidinstruments.com version 0.2. Okay. What else do we get in the box? We've got a quick start guide. There you go. It's got active cool. That's a magnetic power adapter. There it is. That's some custom magnetic power adapter doodad. Interesting. That's how you connect it up to your Knotworks. And we've got some power supply leads in there. We've got our mixed signal leads. We've got USB-C. And we've got a couple of low bandwidth probes. That'll only be like 50 meg or something. Oh no, 100 meg. There you go. And there it is. There's our little magnetic power supply adapter. Why go for something custom like that? I don't really get it. It can't be powered from that USB-C port? That would have been the go, I would have thought. Wah, 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 wah. Can you spot the problem? This is an Australian plug. It's got the screen face mask, but where's the compliant insulated pins? Whoops. Well, you know what we say here on the EEVblog, don't turn it on, take it apart. And yes, this is going to be, no screws. Oh, do I have to get the rubber baby buggy bumpers off? I might. Oh, that's a bummer. Anyway, from memory, talking with them, I might have this wrong, but the founder of Liquid Instruments was in the scientific field or something. So that's what this was originally designed for specific scientific, yep, there it is, specific scientific, it might be easier if I just cut that away, specific scientific instrumentation. Oh, there we go. Oh, geez, that's tight as a nun's nasty. Anyway, I believe designed for the scientific market, because and the software is designed around that, and the specific, because this is the low end one. They originally started with the high end one. Can just lift the skirt there and get that out. So yeah, they started targeting the specific research, physics research and stuff, markets and stuff like that, where they specifically, everyone's making 12 or 14-bit scopes these days, but back then. But yeah, they were specifically targeting those sort of research markets rather than the general engineering. Damn, this is ridiculous. But now, yeah, with this low-end one, they're branching out into the more generic sort of lab market. And from what I've seen of their software, damn, it's impressive. The amount of functionality they got in it. Of course, this isn't the cheapest USB scope out there. It's not designed to be. You're paying for the software just for an analog discovery, for example. You're not paying for the hardware. You're paying for the software and all the effort that goes into that. And as I said, so it's supposed to have 14 instruments in one. I'll put up an overlay graphic here, because I'm probably not going to be able to get around to testing every single function. Damn! There we go, got a bigger shaft on it. That's what she said. So yes, it's all about the software functionality. Oh, there we go. Oh, there we go. The bottom's come off. Oh, we're in like Flynn, but we're being mooned. There you go. Yeah, nice metal threaded inserts there in the case. Yeah, that's pretty groovy. Got a BGA under here. That's certainly one big FPGA with built-in ARM processor, you know, a zinc or whatever. We've got some linear regulators here. We've got the sample memory there. You know, there's nothing fancy. This is not a high-end oscilloscope input. It's only, I think, maximum of plus minus 25 volts. So you're not going to see a full, you know, oscilloscope front end on this thing, but you know, it's going to be good enough for Australia. And any sort of like general purpose, like lab stuff, especially education, and just basically dicking around on your, you know, bench with your usual, you know, low power product designs and stuff like that. So as I said, I'm not a fan of that magnetic input. I'm not sure why. Okay, well, maybe because, yeah, like if you're using this in like in educational environment or something, then, you know, people are going to like rip the USB leads and things like that. So I guess that's where their thinking is with that magnetic power interface there. But got our logic inputs here. We've got our clamping inputs. I don't know if you can program individual threshold levels. Maybe that's an individual comparator on each one. I don't know. Got a backup battery there. Where's that going off to? Something. Nothing to write home to your mum about on the bottom here. But these are our power supply interfaces over here. They've got nice lock-in washers on there. Very nice. You know, these aren't high power power supply outputs, so don't expect anything fancy. So that's the power supply stuff around here. So, you know, but still very useful when you can have 4 individual channels. You could, you know, have different supply rails for your FPGA you're powering or something like that. Yeah, there's not a huge amount extra on there. We're going to flip it over to see what's what. Anyway, it is looking very impressive so far, and hats off to them for wanting to design and manufacture here in Australia. So I don't know who's manufacturing it in Melbourne, but probably just some assembly house in Melbourne. But all the design for this thing is done in Canberra. But we won't hold that against them. Can I get... It looks like I might have to clip out the front panel for the B and C's before that's going to come out nicely. Well, that was a complicated bit of snapoodly there. So yeah, hats off to the 3D designer there. And they would have had fun. And can we get this out? Beautiful. It's very nice fit to envelope design. Very impressed. And... well, there we go. There's our big heatsink under there. Whoa, there's actually a heck of a lot of weight in that. That is massive. They've got a massive heatsink over there. That weighs it down, gives it a bit of heft to help keep it on the bench so that leads don't pull on it and drag it across the bench, but also used for heatsinking as well. It's quite substantial. So let's do the flip, and what do we get? Oh yeah, there we go. So some large thermal pads over here. Got some stickiness happening there. Anyway, some large exposed thermal pads like that, which then go onto the sill pad, which then goes off to the main thing. Yep, and Xilinx Zinc called it. That was pretty obvious, wasn't it? There you go. Should be able to pull the exact part number off there. Can't read that on the camcorder screen, but there you go. We've got ourselves a little shielded can there. That'd be for the oscillator and PLL. This is interesting. SVT, SVtronics Inc. That's an American company bringing manufacturing back to America. So yeah, that's the probably the bare board they're getting from them, I suspect, because unless they have like an assembly house here in Australia, in Melbourne, because that's where they said this was manufactured. So yeah, it might be using an American PCB. Of course, we do very little. I think there's only 2 companies in all of Australia that do bare board manufacturing here. One is like a high-end military one, Lintronics, and the other is a lower-end one, which could easily do this board, I think. But anyway, I think that's where they're getting the PCB from. Interesting. Must have the Wi-Fi's too, because there's your Wi-Fi chipset there. And as I said, like the analog front end, nothing to write home to your mum about. I will have high-res photos of this available on EEVblog.com, of course. There's a switch up there. That doesn't go to the outside, so I'd say that's something to do with boot and in-serial programming, which we've got here, of course. Got the bottom of the power supply section here. Down here, we've got some serious common mode choke action happening here. A big ass inline resettable fuse there. That's enormous. Need some high-res photos to get up close and personal on the analog front end there, but quite a few missing parts, so I'm not sure what's doing there. This, have they got an expanded model of this one? They might. Anyway, so these are our analog inputs. These are our DAC outputs there. I had completely forgotten about the active cooling in this thing. Where's the fan? Where's Wally? Well, it's actually up under here. This is all the heatsink here. And if we flip it over, once again, I've got to take out those 4 screws there. We can get the top side off. There's that gigantic heatsink there. And look, beautiful. We've got our little fan here, and that's blowing. The fins are in the right direction. Excellent work. So that's blowing directly across the fins and out this side here. I don't know how loud this is. It's probably quite silent. Probably doesn't need much at all. But yeah, that's a nice touch just to get a tiny little bit of airflow. You don't need much over such massive, such a relatively massive heatsink and fins there. So that's interesting because there's a heck of a lot of surface area in there. So that's really neat. I like that. This thing is like a very impressive design. They put a lot of effort into it. Hats off to the design team in Canberra for this. This is just really something else. And I even like the design of the light pipe here. There's our multicolored LED on the front there, and of course you've got to get that through from the backside over to here. And it doesn't sit in there like that. It actually is completely molded into the front like that, so it stays in place. Like, that's fantastic. So there's some nice engineering that's gone into this. I really like it. So yeah, hats off. And of course you can afford to get stuff designed and manufactured here, or manufactured here in Australia, when you're not doing like a low price point stuff, trying to save every dollar, which they're not. So I'm not sure how much margin they'd be making on this small product. They'd be making some, but of course, they're going to be making larger margins on the larger products. Like one of the biggest ones is like $60,000 for the real 2 gigahertz high-end crazy bit of kit that does insane stuff. So I do believe this has had a low jitter clock as well from memory. I think they discuss that. Well, the higher end ones would definitely have that. Not sure about this one, so yeah, she's probably under there. Anyway, yeah, hats off. Some very nice engineering there. You're certainly getting your money's worth. Not to mention the software. There's 2 things I wanted to go into detail here. One is how they're doing the power supply, and the other is a quick look at the front end. Now, the power supply is very interesting. At first glance, without reading the numbers, I thought these were just linear regs here. They're not. Now, this brings back some memories. These are Burr Brown jobbies. All the Burr Brown fanboys go wild. OPA 547. And these are a high voltage op-amp with current limiting, pretty much specifically designed for power supplies. Now, I actually looked at this back when I was doing the micro supply. I can't remember at what part. Now, they're not cheap parts. I think they're $4 or $5 a go or something like that. But they're basically a complete power supply in a chip that has a current limiting input pin on it that you can feed in a lower current, like 0 to 150 microamps on one of the input pins, and that translates to 0 to 700 milliamps adjustable current limit on your output. So they're actually an op-amp, and we can take a look at the data sheet here, and they're actually adjusting the current limit here using these microchip 45HV51s. These are a digital pot, so they're using that. And so there's 2 ways you can do the current limit in this thing. You can do it with, as I said, like a current source. You can also do it with a voltage source, or you can put a digital pot. So they've decided to use a digital pot here. So they've got 2 identical channels here, basically. So what is that? They doing a plus minus thing. I'm not sure. They've got supposedly 4 independent outputs, but I haven't looked at the specs yet. But of course, because these aren't switching converters, you don't see any switching components here. There's no inductors, there's no magnetic components. That's how you can tell if something is a switch-in regulator. Are there magnetics in there? Is there a big-ass coil there? And the answer is no, it's not. So these are going to be operating in linear mode. So if you've got power supply coming in at, say, 12 volts, and say these are 0 to 8 volts output, say, because I don't know what the spec is, but you're going to have some, like, a dropout voltage on there. So your output can't go right to the maximum of your input voltage. So you've got to have some sort of dropout voltage on this thing. So it's a linear pass element. So that means, because it's not switching, especially at, say, low output voltages, say you've got a 1.2 volt rail or something like that, and you're maxing it out at 700 milliamps maximum output thing that this is current that this thing's capable of, then you're going to be dropping like 10.5 volts across this at like 700 milliamps, and well, that's like 7 watts or something dissipated in this. And if you do that with Bose chips, well, there's 14 watts being dissipated. So that fan might have to ramp up a bit to actually get the heat out of that. So yeah, there's a penalty you pay there, but the positive side is there's no real switching noise to be had here. So yeah, linear pass elements, these are really cool. We'll have a quick look at the data sheet. So here it is, high voltage, high current, and technically it's an operational amplifier. Single supply range from 8 volts to 60 volts, so can go pretty high voltage stuff, or you can do dual supply. You can split them there if you want. High output current, 500 milliamps continuous. I thought it was 700 milliamps. Anyway, yeah, so 500 milliamps, that'll probably be the spec of this Moku Go here. 6 volts per microsecond slew rate, and they're designed for power supplies and test equipment. Go figure. They've got over temperature and over current protection, and there's the pin there for setting the current limit. As I said, you can actually force a current into there, but if we go down, we'll have a look at the internals for this. Yeah, so there's the internal. So effectively, it's got a built-in 4.75 volt voltage regulator and a built-in 31.6k resistor, and then you can, so if you put an external resistor here, so with the total resistance there, you can figure out what the current limit is. Yeah, they've got 750 milliamps here. So yeah, I'm not sure where the discrepancy there, 500 in the banner spec and 750 down here. Anyway, or you can drive it with a DAC, which is what you're doing over here like this, or of course this can be an adjustable resistor like they've got in this design here, a digital pot. So yeah, just a really cool bit of kit. And basically all you need to do is feed into the input a DAC from your microcontroller that sets the voltage. You don't even need a DAC. You can just use a PWM and an RC filter there, and you can get the DC voltage on the input to the pin, and then just have it tied as a voltage follower, and Bob's your uncle. Like, that goes to your output here, and these are designed for like stable into sort of like any sort of load. That's their job. Yeah, thermal protection at 160 degrees there by the looks of it. And it's got a pin to disable your output as well if you want. Oh, use it as a motor drive circuit. Yeah, why not? Now, they do talk about output stage compensation here, though. For normal operation, output compensation circuit is not typically required. However, it is intended to be driven at a current limit. An RC network may be required. So yeah, that's just acting as an RC snubber network there. Generally provides excellent stability. Some variations circuit values may be required with certain loads. So yeah, a general programmable power, well, they talk about, you can use it as a programmable power supply, so it's going to be pretty stable. I don't ever remember testing it, but I remember thinking, yeah, this is certainly a nice, simple option, but yeah, the part's a bit pricey, but in a high value add product like this, it's not really a problem. But I don't know, is a micro supply back on the menu? Meat's back on the menu, boys.
Looks like meat's back on the menu, boys.
There's your example resistor controlled programmable power supply here. So you can just put your pot there, and Bob's your uncle. Like, you can gain it up, so you can use it as a follower, or you can gain it up, as I said, and boom, straight on the output. It's all protected, everything, even short circuit protected, and you can even get like a thermal shutdown status LED, and then the current limit adjust. So if you want to build yourself a simple do-it-yourself power supply, the OPA 547, perfect. You can just put two real knobs on the front panel like that, and Bob's your uncle. It's really quite nice. Or if you want to get fancy, there you go. They're showing you using it with a DAC there. But yeah, it's a really nice part. It's worth the $5 or whatever it costs. And as for the analog front end here, no surprises. It literally is, they're using an AFE, analog front end. There it is. It's a TI jobby, and it does absolutely everything. So let's take a look at the data sheet for that. And here it is, analog front end wideband mixed signal transceiver. So it's got a dual 12-bit, I think they're using, 125 meg sample per second in this design here. It's got dual 12-bit DACs as well. So yeah, they really haven't optimized this design for cost, because they know they're not selling into a high volume, low cost market like your Rygols and your Siglents are. They're selling to a more specific scientific educational type thing, where you sort of like you're paying for the value add on the software side of things. So yeah, they throw that in, no worries. The analog front end, very simple. I'm not even gonna try and find out which parts there are. It's like a 30 megahertz bandwidth. I'm not sure why these parts are missing. They might have an additional model with some extra goodness. I don't know what the deal is, but yeah, there's no 50 ohm termination. There looks like they got a solid state relay here, which that looks like the AC cap there. So that's the AC DC coupling. They're probably injecting some offset stuff as well, and that's just coming in to your main differential driver, and you can see that's driving differentially over to there like that, and that's channel 2, and then differential output from the DAC here, and this is just driving LM393. That'd just be for some offset stuff or whatever. Yeah, they got another solid state relay. They've admitted the back-to-back diodes there on the output. I'm not sure why they've omitted those, but anyway, just a dual channel DAC, and it's just all in one there. And I won't try and get the can off this. This is obviously the 10 megahertz reference oscillator under there. No, it turns out that's a USB transceiver there. So anyway, yeah, there's some chippies under there. So they've probably got the PLL under there. So that's all she wrote. So they haven't tried to do anything tricky at all. They've just gone, well, let's just buy the solution that works. And well, this thing's going to work. It's going to do exactly what you want. And that analog front end is going to do exactly what you want. You don't have to do anything really much fancy on the input here, because it's not a full voltage range oscilloscope input. Not even sure what the lowest voltage range is, but yeah, they've just bomb engineered their way out of this thing, and perfectly valid approach. I'd do it too. Now, unfortunately, it seems like the power supply in this thing is optional extra. I didn't know that. So I've got the M2 model, it's called here. So an extra $200 for the 4-channel power supply. That's a bit of a downer. Yeah, the base model without the power supply is $599. And so much for your 14 instruments. You only get, for your base price in either model, you only get the ArbGen, the data, well, this is still a lot. You get the ArbGen, the data logger, the logic analyzer, and pattern gen. You get the scope, of course, the spectrum analyzer, and the waveform gen. But you don't get any of the extra fancy stuff, which makes this thing like really cool and a step above everything else, like the digital filters, fur filters, a frequency response analyzer, bode plot, basically a laser lock thing, a lock-in amplifier, PID controller, phase meter, time and frequency analyzer. So unfortunately, they're all optional extra, and you can get them bundled as well. So pretty pricey, but so the software would want to be really good. Let's take a quick look at it. And so it's installed, no problems whatsoever. It's detected my Moku Go. I've got it connected to the Ethernet here, and I can go in there. I can configure it. What can I do? You can configure your lid color, because you can buy it with different lid colors on it. Like, so I got the blue one here, but you can order different ones, and you can just set that in the software. I guess you'd care because it's going to show differently on the screen, because you can, as I said, you can network multiple units together, I believe. Even though I've only got one, I believe you can do that. So maybe it shows up. If you've got some complex setup or something like that, remember, these are more for like, research purposes and stuff like that. You could have some complicated, big, massive physics experiment or something. You could have a dozen of these things, and you might want to have them with different colors to differentiate the different functions that they're actually doing. It can work as a Wi-Fi access point, can it? That's interesting. Anyway, I'm not going to try and take a look at that. Now, we can actually do a demo here, so we can go ahead and we can demo any of these things, but well, you can download the software yourself. If you're looking at buying something like this, then download the software and have a play. They've got so let's say we wanted PID controller, for example, which is really cool. And look, this looks absolutely fantastic, right? Their graphics here, mwah, beautiful, right? Absolutely fantastic. So you can control any, look, oh, there we go, popped up a waveform, right? We can control our offsets here, and we can like open and close that. Then we can set up our controller here. Look at this, it's incredibly versatile. Sorry, my head's in the way. Can't easily move my head with the ATEM switcher. I haven't got it configured. But you can set up your proportional gain, your integrator crossover, integrator saturation level. It's pretty cool. So let's open our the real Moku here, and it looks like maybe I've gotten these options. It knows my serial number, so they've given me these options because they're enabled. It's not saying purchase or whatever. And whilst these add-ons sound expensive, you've got to remember there's something like a lock-in amplifier, for example. This is a 20 megahertz bandwidth lock-in amplifier. It's not, you know, really high RF or anything, but if you don't know, a lock-in amplifier is designed to extract a signal, like a reference signal or a clock or something, from a noisy signal. Very useful in like all sorts of physics and research and measurement and stuff like that. And they're usually very expensive bits of kit, even on the second-hand market. Go and try buy a second-hand lock-in amplifier on eBay, for example, and you know, like a Stanford research lock-in amplifier, and see how much they are. But yeah, we can set our local oscillator frequency down here. Can we set it that precise? Can we? It's pretty good. And the higher end versions, this Moku Go has only got like a 20 ppm oscillator in it, but the high end ones, the ones that, you know, you can get a $50,000 version of this that has a really schmick oscillator in it with incredibly low jitter and all the rest of it. But let's try and actually, let's just open our scope and let's see what we've got. Right, so looking at our oscilloscope here, okay, we got our channel A, we got our channel B, no worries, we can turn those on and off. We can select our AC-DC coupling. I'd prefer not to have to go into a menu to do that, please. Like, you've got plenty of, like, just put coupling, AC-DC, you've only got like 2 options there. It's not hard. And we've only got 2 ranges on the voltage. We've got 10 volts peak to peak, so presumably plus minus 5 volts there, and we've got 50 volts peak to peak. So no low signal level capability at all. So that's disappointing. Why does we can drag this around, why does this stay at 200 millivolts per division, right? I mean, where's our like per division thing? Where's our traditional oscilloscope settings for like per division? But it does look like you can set the input, you can route the input directly, the output directly to one of the channel inputs. That's pretty cool. If we right click on our y-axis, okay, we can auto scale, we can add tracking cursor, time cursor, okay, but like, yeah, I'm not seeing it. That's just helpity doodah. Yeah, we can turn on a math channel. Okay, cool bananas. And interestingly, like there's 2 channels, and you can assign channel A to input 2 if you want, I guess. Because like if you have this as the output, then we should be able to select that as input 2. So channel A can be input 2. That's confusing. So yeah, if you're looking to use this as like a regular oscilloscope substitute, it doesn't have any low voltage ranges. It doesn't have an input amplifier at all, and you don't have your traditional volts per division settings. You can't change it. You can just like auto scale or whatever. Once we get a signal in here, we can have a look. But yeah, not liking that at all. And they've got all this wasted space under my head here. There is nothing on this screen, yet the time base here, okay, all of this stuff for the time base could have fitted on the main page here. Why do I have to change over to time base here? I just don't get it. Okay, we can do roll mode. Okay, cool bananas. We got precision, peak detect, and deep memory mode. Okay, so deep memory mode. So there's some trade-off there. We can do interpolation, sine x on x, linear or Gaussian, and averaging. And then we can just turn up our number of averages there. Okay, it's all pretty basic stuff. But then, like, what? I have to manually type in Like I want 10 milliseconds like that, and it's not, there's no traditional per division. It's the total width of the screen. And they don't follow that convention for the vertical here, right? It's like, yeah, if I whack it in the middle like this, is there any way to just to center it, right? We've got like basically plus minus a volt, okay? We've got basically 200 volts per division and 10 divisions total. We've got 1 volt peak to peak, but we're in 10 volt peak to peak mode? How does that work? So obviously they're like prioritizing just waveform view over your traditional oscilloscope interface, I guess, so to speak. And trigger here, we've got our auto, normal, single. Yeah, that's no worries. And we can trigger off any of the inputs. Can't trigger off the math stuff though. Why can't we trigger off the math stuff? I would have expected something with this software, advanced software capability to be able to, because it can do all the other magic stuff and can do your lock-in amplifiers and your PID stuff and everything else magically in software. But you can't trigger off a math function. Okay. Nth event. Which event though? What event are we talking about? We've got trigger hold off. We can just do edge and pulse triggering. There's no advanced triggering stuff. I assume this software is the same even for the most advanced units. But please correct me if I'm wrong down below. But yeah, I mean, very basic triggering functionality, auto, noise reject, HF reject. Yeah, but there's nothing fancy. There's no fancy types of triggering. Maybe we can trigger separately from the pattern, you know, if you've got your digital inputs, maybe you can do some, you know, serial triggering or something like that. Yeah, it's very rudimentary. Okay, we've got some measurements. We've got a voltmeter. Okay, cool bananas. And the reason it's negative 700 there, I do actually have these connected to the outputs. So that's why there's going to be some offset there. The other thing is here, I don't see the ability to, where's like the mixed signal stuff? Okay, we can go over to here. We can go over to the logic analyzer. Okay, we can open our logic analyzer, but where do we have our mixed signal capability? Where can I put, like, you know, it's not like I can do a plus up here, add math channel. Okay, it does protocol decoding. Okay, cool, it'll do that, I presume, in software after it's captured it, but I'm not going to go into, I could spend hours and hours and hours long video testing every feature of this thing, but that's not my intention. So I just want to like have a surface look at this thing. But yeah, one of the beautiful things about mixed signal oscilloscopes is it's in the name, mixed signal, although they don't market this as a mixed signal. They just say it has a logic analyzer and it has an oscilloscope. But to me, that's mixed signal capability. Why can't I add in on the same time base, on the same timeline, why can't I have my analog signals as well? Don't see it there. Now, we might be able to put multiple instruments on the screen at once, would be my guess, like separate windows would be my guess, but I'm not seeing like any ability to like dock any of these windows though. I would have thought that would be a given. Like, you know, you go up here and that just goes like to there, but I can't like, I can't just dock another thing. I can go, okay, select another. No, that's just like selecting another instrument. Remember how I said you could network them all and you can have multiple ones, and so that's what that plus button is there for. So it's not that. You're already using Moku on another window. Show window. Yeah, looks fancy on the surface, but once you get into it, it's kind of getting a bit inflexible, so to speak. What is this? Upload to cloud. There we go. That's pretty cool. High-res data, there we go. We can export our high-res data to CSV, to all these different formats. Don't even know what half of those are. I'm sure that's useful for lots of like, you know, other research software or something when you're exporting data. That's what mainly this product is designed for. But if you're trying to, with this lower cost product, if you're trying to target the more general test instrument market, you've got to make it look and feel like, you know, a proper test instrument. Yeah, so we can like, we can switch instruments, okay, but that's like, that's not helping us. Like, let's go into our waveform generator here. And by the way, I'll be silent here, see if you can hear this. This is the fan noise. It's annoyingly loud. It's not loud, but it's loud enough to be annoying. Just sitting here in front of me on the bench here. It is like the loudest thing here. It's louder than my National Instruments virtual bench. And my little A10 Blackmagic switcher has a fan built in. There's no noise, no, audible noise. This thing doesn't seem to have any like temperature fan adjustment. It's not getting hot at all because it's pumping that fan at whatever, at a fixed speed. So yeah, thumbs down for the fan in this thing. They need some temperature control over that. And I'm not even doing anything with it, with the power supply. Maybe this is the lowest fan setting. Okay, so let's set 1 megahertz there, okay? So we've got a 1 megahertz sine wave output. Does this turn it on? I assume that just turned it on. 1 volt peak to peak over here. So yeah, like how do I go to my oscilloscope? Like I want both of these things on at the same time. It's got to load it again. And input. Where is I've got output 1 connected to input 1. I'm not seeing any signal. No, hang on, there is a multi-instrument thing. What is it? Build your system. I don't want to build my system. Just give me mixed signal view. Right, okay, so slot 1, here we go. Yes, it looks like we can have multiple instruments. So, I'm going to choose my oscilloscope, and I want slot 2. Do I only have 2 slots? What's going on? Okay, let's just say that I wanted my logic analyzer. Oh, no, right, this is how we feed outputs from things into things. Incredibly powerful, okay? This software can do a lot if you're doing your physics research and you're doing your whatnots, all your academic experiments and stuff like that. It's probably extremely cool functionality, but if you're just looking for day-to-day mixed signal scope, this is not doing it, and we can sync them. I don't know, I'd have to RTFN. And bus 1, okay, so we've got multiple buses, input digital I/O, output, apply changes. I don't know what I'm doing. No, I thought this might have been like a multiple view thing, but it's not. It's where you can get outputs from one system into another. So you can get, your output from your PID controller and feed it into your something else, which is feed it into a filter or something, which is really cool. But no, we're not doing that here today. So I'm going back to my waveform gen. I don't like that it has to load up each time I've got to switch between them. Like, just give me some tabs up the top. Just like go between them. Jump between the different instruments that I'm currently using and working on. We've got my logic analyzer, I've got my waveform gen, and I've got my oscilloscope. 3 basic instruments there. And it's just messy. As far as I'm concerned, I've got output 1. Look, it's 1. It's like a 0 means off. 1 means on. I've got my coax connected. I swear, output 1 into input 1 of the oscilloscope. I should have a 1 volt peak to peak, 1 megahertz sine wave. Anyway, let's see what different waveforms we've got. We've got sine, square, ramp, pulse, noise, DC, but I've got that switched on. I swear, and where do we set, our output parameters? Is it into a 50 ohm load? Where's our setting? Oh, here it is. I missed the little, no, copy settings from output 2. Well, what are the, no, that's just the settings are, what? What, so I can't even select a 50 ohm or a high impedance load for a waveform gen? Seriously? And there's nothing over here. Oh my God, this is so rudimentary. It looks like $1 million. The usability, modulation, okay, we can do sweep, burst, PWM, FM, AM, okay, it's not too bad. It's not nothing to write home to your mum about, but it's okay. I'm going to assume that output function gen still works when I go back to the oscilloscope screen. It'd bloody well better. There we go, and stick my finger in it. Thumb. I've got to go over to here to change the time base, and then, right, so I can use my control wheel and up and down to change my vertical axes, okay, and I can use Alt, there you go, Alt, and my scroll wheel changes the horizontal, okay, but you don't get your standard, per division stuff. Oh, no, don't like it. Can put roll on. There we go. Sticking on the thumb. It works, but why am I getting nothing on the output of my function gen? Output on. Do I have to feed this into another oscilloscope to actually check that it works? I've resorted to my National Instruments virtual bench software. There's the output. Okay, so, right, so I'm going to leave that there. I'm going to leave that running. Okay, and I'm going to go back to, oh, look, okay, we've pulled that up. Can we, no, that's just, that's a Windows thing. Okay, so it's not docking inside the software. Okay, so you could, maybe you could dock multiple windows with software. I don't know. Anyway, I'm going to go back to the oscilloscope, and that signal is still updating, right? So let's go into this. Are you kidding me? The function gen turns off when you enter the oscilloscope. That sucks ass. That is ridiculous. So 0.5 megahertz, there it is. Okay, yeah, no worries. And if we go out of it, it's still there. It's still there. But if I run the, well, let's just run the logic analyzer, right? We'll just run the logic. It's switched off. Like, I just love that it can do all this stuff. But if you can't do something simple, this is a dual channel function gen with a dual channel oscilloscope, and we can't use them at the same time. I thought I must be doing something dumb. So I thought I'd RTFM. And, well, the user manual, they've got a separate user manual for each one of the products. Moku Go user manual, but it's for the Arb Gen. So you open that, and it's the waveform generator user manual. So it's like they don't have one user manual, and so it's obvious. Look, it jumps straight into the user interface for these are separate instruments. Everything is a separate instrument. You might be able to tie them together with that weird convoluted thing that they have, but you can't just use it as a like a regular mixed signal scope. Who thought this would be a good idea? Okay, it's great if you want your infinite money glitch because you want to buy, the customer has to buy 3 separate units to do 3 separate basic things. What alternate reality have I entered into? How can this be a thing? No, wait, hang on. Look, there's a little waveform thing below, down here. I found this because I asked Grok. It's probably in the oscilloscope user manual, right? And we get the function gen, and we can get a function gen, but you'll notice that there was no ability to go into mixed signal digital and analog, so we can't call up digital and analog at the same time. But it looks like they've at least thought about this in the convoluted way that they're doing it, that they can have okay, the function gen, there we go. We just turned on signal. Okay, we got 10 megahertz. Okay, so let's lower that to 1 megahertz, 1 volt peak to peak. What do we do? Was it control? Yeah, there we go. And there's our signal. Oh, no, we can't go time base at limit for, oh, I'm in roll mode. Yeah, don't want roll mode. Oh, that was a pebcac. There we go. And they're filling in. Look, they're filling in the area under the curve. Why? Why is that a thing? How do I turn that off? Auto scale, export data, add tracking cursors, no. Toggle channel, trigger settings, no. But anyway, here's our trigger over here, and boom, it's now, yeah, it's off in La La Land now. Boom, now it's triggering, no worries. Got our rise in, fall in edge, we can do both. Boom, there we go, flippity-doo-dah. Okay, so we can do that, but we still can't, there is no ability for us to do the mixed signal. So I'm still angry about this. I still think this sucks. I would have preferred to have like the ability to like dock this, like to take this and dock it, you know, like within the program, of course, not Windows docking. But you saw it, if we used the function gen module and the oscilloscope module at the same time, because that's the obvious thing that I did first, and then it just wouldn't work. When you go into the oscilloscope, it switches off the function gen, which is nuts. So you had to choose this specific function gen mode using this waveform view here. So, but why? So it works here. If we switch off, right, we can get rid of this for visual cleanliness. But if we go into the function gen module, then back into the, set it there, and then go back into the oscilloscope, it switches off. What the? Yeah, so it looks like they've like copied the code, so to speak, from the function gen module into the oscilloscope module, where they've deemed that, oh, okay, well, people are obviously going to want to use the function gen with the oscilloscope. That's pretty basic. And then they've manually added the ability, duplicated the functionality of the function gen into the oscilloscope module. But if we go out here and go into the function gen module on its own, then it'll switch off. Please make it make sense. Can somebody explain to me why they've done it this way? What possessed them to do this? And then if we go out of here, is our function gen still running? Yes, our signal is still running in the background. Well, that's a bonus. So can we do our spectrum analyzer here? Nope. Once we opened our spectrum analyzer, our function gen died. So in the spectrum analyzer, there's no equivalent way of function gen thing down here because they haven't added the capability. The whole idea of having this with all these cool tools is that you can experiment with all sorts of crap happening. You want to be able to output waveforms, you want to view them in the spectrum analyzer and have the oscilloscope view and have the digital view all on at the same time. Okay, so we can switch on power spectral density units there. And, okay, resolution bandwidth, okay. They do have the output. Look, instead of having it down here, they've got it in this tab over here. Look at this, output. So we can now switch, there we go. We can switch our 10 megahertz on. Oh. Consistency, please. And it looks like we don't have the full function capability. We can only output a sine wave. That's it. We can't output any of the stuff that we could get in the function gen. What? Why would you? Why? Oh, unless you deliberately program in the limitation into the FPGA to do all this stuff at once. I can't see why you would implement it like this. So we can turn on both outputs, but we only get a sine wave and that's it. And there's no modulation capability. So how am I supposed to look at modulation stuff? No, I'm just so disappointed in this software. I don't think I'm going to go any further. I was kind of looking forward to, it looked really good from, a few times I've played with it at the trade show stand and looked at this thing. I thought, yeah, this looks really advanced. This looks really schmick. Okay, so it looks like the way that you have to use this is the multi-instrument mode with build your system. Okay, you've got the bus here and you've got only slot one. It looks like you've only got 2 slots. So you can only have the 2 instruments. So I've got a waveform generator connected to the spectrum analyzer and you can reroute these things, up to the bus. Looks like you can do up to the bus at the same time, but I guess the bus might be for multiple networked instruments, I would be guessing. Haven't RTFM'd on that one, but that'd be my guess. But yeah, it looks like we can only have 2 slots here. So I'm not seeing another way to add one. So we apply changes to that. Okay, so we're running that and then we can we can send this out into a different window, right? So I've popped this out. So we've got our waveform gen. I'm doing an FM modulated sine wave. So I've got a 10 megahertz carrier frequency with 100 kilohertz FM modulation. And, we're seeing our 10 megahertz signal there, but we can't it doesn't have the sampling resolution to actually get that. So, yeah, we're just not going to be able to get that. We've got absolute minimum there, what we can do, and no, we're just not going to be able to do that. We can run some averages here. But yeah, so I could drop that down. So we do have our multiple instruments, okay? So we can have 2 instruments running and then we can connect them in convoluted ways, which is flexible, granted, right? So if we have 100 kilohertz, we can add tracking cursors, power cursor, frequency cursor. Okay, cool bananas. I've got 100 kilohertz just sine wave here, and this is the best we can get out of this thing. At I can't lower it any more than I can't get the resolution bandwidth any lower than that. So if you're analyzing low frequency stuff, it's no good at all. It might be something that I'm not doing right there, but I don't think so. So yeah, you're not going to be using this as like a dynamic signal analyzer or anything anytime soon. It's not going to replace my HP jobby. So here's the data sheet for this multi-instrument mode. Combine instruments to build a customized test system. Multi-instrument mode on Moku allows you to run up to 4 instruments simultaneously to create custom test sequences. Awesome! Each instrument has full access to the analog inputs and outputs along with adjacent instrument slots. The slots are connected by low latency signal paths so instruments can run independently or be connected to build sophisticated signal processing pipelines. Dynamically swap instruments in and out without interrupting those running in tandem. For advanced application, well, except when your bloody function gen turns off because you opened your oscilloscope or whatever. So it looks like the Moku Go here only has, 2 instrument slots, limited output latency, blah, 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 right? So you can get up to 4 instruments on the Pro model, but if you have to ask the price, you can't afford it. And yeah, okay, great. We can do all this fantastic capability. Low latency, closed loop control design and characterization. Okay, groovy. This is the most powerful feature of this thing. This is why you buy this thing. You don't buy it as just a regular USB oscilloscope. You buy it because you want to do all this advanced signal processing stuff and design systems and things like that. So that's its target market. That was its original target market. That's what it still is. Now here's the silly thing. This is only a couple of pages. That was the data sheet for the multi-instrument mode. The others, all the other things, look, they have user manuals and data sheets, right? The multi-instrument mode, the most powerful thing about this product, they don't have a proper user manual for it. Are you serious? It's not like this product is new. They've been going for I think 7, 8 years or something like this. And they got really nice hardware and everything, and the software looks great on the surface, but you can't tell me how all of this stuff works. How do these buses work and how do all this input? I can figure it out myself, I guess, but you got user manuals for all the other instruments and yet not one for building your system. I don't get it. And they've kind of thought about this, as I think I said, when you're using the oscilloscope, for example, you obviously kind of want to, output some signals as well. So they've added the ability to use the function gen within the oscilloscope modules, like they copied and pasted the code out of there into there. And then if you're, what was the other one? It had a tab. If you're in the spectrum analyzer, was it? You can then output the signals, but it's in a different tab. It's not the same user system as what they had for the oscilloscope module. And you shouldn't have to do this build your system, and they know that, just to use those basic instruments, so they kind of tack them on to the instruments, and it's I don't know. No, I feel like I've been let down with this thing. It's a bummer. Frequency response analyzer, which is an optional extra, by the way, in2 divided by out1, in2 divided by out2. Okay, here's our output, so they know, well, okay, it's a frequency response analyzer. We want to get our bode plot, so we need function, so we need a swept sine here. We can go up to 8K points here. Okay, so I've got my out one connected to my in one. So can we just run that? Normalization removed. It's going to be 10 seconds or something, 11 seconds. Yeah, okay. So we're sweeping. Okay. Whoop. There we go. Okay, we can go to 20 megahertz maximum. So I've just bodged in a 15 megahertz Butterworth filter. I'm not worrying about any termination or whatever, and it's just, yeah. Okay, it's doing something. We haven't looked at the arbitrary waveform gen. One thing I do like, the arbitrary waveform gen looks good. Double-click the graph to edit the equation. Right? Pretty advanced stuff. Okay, that's pretty groovy. Or you can edit segments. Oh, we can do multiple segments. Okay, this is very powerful. This is kind of impressive. Okay, but oh god, I could play with that for hours. And our different types: sine, Gaussian, exponential rise, cardiac equation, custom. Okay, yep. So we can do a right click on the graph to load a waveform. We can actually load a waveform, load from file. Yeah, cool bananas. We can't just draw it, can we? Nah, that would have been nice, but I'm not leaving here until I find this power supply. Plus, no, that selects a new device and opens, no, go back out of here, select your device, no, right, I'm selecting my device. This is my device, this is my physical hardware device. These are instruments, okay, a power supply is not an instrument. Do I have to go into the oscilloscope before I can open this? Here it is. I thought I saw it before. There you go. So I have to go into one of the... Can that work on any of the instruments? Let's just say lock-in amplifier, for example. Yes, we can. Okay, so the power supply calls up a separate window, but you can't call it up from the main screen? Okay, at least this goes out to its own window, okay? So I can, like, I should be able to go back here, yeah, and the window stays open. Okay, wow. So we've got plus minus 5 volts here, 0 to 150 milliamps, so we can switch that on. Okay, so I'm going to try and trigger off the power. I've got the power supply, channel 2 of the power supply connected over to here. I'm going to single shot trigger. Channel A, yes, okay, and rising edge, and we'll set the level, noise reject, H reject, no, okay, so let's trigger, okay, we're waiting, and I'm going to switch on my power supply, boom, there we go, oh, there we go, yeah, not many points there, let's try running that again, shall we, trigger, there we go. So that switched on very cleanly, didn't it? I'm liking that. Okay, yeah, no worries. And I did the exact same thing with channel 3 over here. So we just go boom, and basically it's the same. So yeah, no worries. So yeah, I don't see where this thing fits into the market. It would be good if the software was like just allowed you to work like a normal run-of-the-mill mixed signal scope. Everything just available right there. No silly fancy stuff. No, just give me the ability to operate like a regular mixed signal scope, please. Because it's all, like, the hardware's capable of all this, right? It's got, you know, dual 20 megahertz or 30 megahertz bandwidth or whatever it is, dual 20 megahertz function gens. Great. It's got all this advanced capability. It's got 4 power supplies built in. And, like, yet somehow I can't even get analog and digital on the screen at the same time. I mean, like, what? I think the value in this is, yeah, you need your PID controller, you need your lock-in amplifier, you need your, like, a fur filter builder. Did we even know? We didn't even look at that, did we? And some of these tools are very advanced. They're really, look at this, right? Really good. So yes, we did look at that, but they can do group and phase delay, impulse, step response, magnitude, phase. Okay, there's some pretty advanced stuff in this thing, and I like the visuals of it. It's just a shame that it doesn't all work together as a basic USB oscilloscope, mixed signal scope. All right, so I'm trying to build a system here, right? I've got a waveform generator, I've got the digital filter, okay? And watch this, if I put this to the signal bus, and I put this to the signal bus, right? This is supposed to be an internal signal bus, right? So we have to, like, the waveform gen has to go to there like that, and then I apply changes, okay? And it's changed back. It's changed back to, maybe it recognizes that's a bad, like, I can't link that to the bus, but then it shouldn't let me do it to begin with. But okay, it's changed back. Okay, so we've got the waveform generator connected to the digital filter, and I've got the output of the digital filter on output 2, right? Oh, yeah, yes, output 2. So that should work, and I'm generating 100 kilohertz square wave with my function gen. It's going into the digital filter. In the digital filter, it looks kind of cool, like, you know, I can do like an 1/8 order Butterworth or whatever. The sampling rate, it looks like they're only these selections here. Okay, but let's go for 3.9 meg sample rate for our digital filter. Okay, I got it rolling off at 100 kilohertz. Just want to see if I can round off my square wave. So this should be running, but it's not. I've got the output 2 connected to my NI scope because I can't use the Moku scope because you can only have 2 instruments at once. So I'm at a loss as to why this is not working. Maybe it's a PEBCAC. Maybe I'm just doing something dumb. But like, I've got it on. I've got the output switched on. Okay? And then I've got it connected. It shows that I can connect it internally, physically connected. There, right? We can connect that to slot 1, output A, which is this one here. Slot 1, output A of the function gen. The digital filter. And then this is supposed to be going off into digital I. Like, I don't know why it just vanishes into the ether there. I don't know what the deal is there. Let me try output number 1 and see if that works. No, I'm getting nothing. My function gen's turned on. Okay, I'm going to have to turn this function gen to also... Okay, I'll do this output number 1 and I'll do this output number 2. Okay, signal output, right? So I should be getting apply changes. There we go. This is output 1. So I'm getting my square wave. Now I'm getting my square wave on output 1. Now, if I plug it into output 2, what do I get? Nothing. My digital filter ain't working. Why? There's nothing else to set in here. Now, interestingly, I noted before that it didn't have the 50 ohm termination output. It's got high impedance termination here. Look at that. So, but I don't know where you actually set that. I couldn't find it. Maybe it is hidden in there somewhere. What does sync do? Instrument slots synchronized. No, I'm still getting nothing out of my digital filter box output 2. So yeah, I don't know what to tell you. Like, this should be as simple as it gets, right? A waveform gen, it does go to output 1, but it also shows I can connect to a digital filter, and that digital filter, it lets me route it to an analog output, yet I get nothing out of the analog output. And then I can't use the oscilloscope to the internal Moku oscilloscope to view any of this because I can only run 2 instruments at once in multi-instrument mode, and I've filled up my 2 slots. So, oh, jeez. Because look what happens. If I go back out of this multi-instrument thing, this output will turn off, won't it? Will it? Will it? Yeah, like it shuts down the windows. It just totally shuts them down. And it shows, oh, no, multi-instrument's still running. So can I run my oscilloscope? Maybe? So output 1, no, there's nothing. No, it's stopped the function gen. There's got to be a way to do this. I'm going back in. Like, I like all the graphics in this, right? It's really cool. Look, we can set our output gain, we can set our output offset, and we can, oh, output A, off. Is that the reason why I wasn't getting a signal? Okay. Oh, check it out. We can probe it. We can probe it. Right, we can probe A. That wasn't obvious. I didn't know what that did. We can change our input offset. Okay, cool bananas. Right, so we're generating our 100 kilohertz square wave. Whoa, there we go. Right, so our input A, right? So there's our square wave. Okay, all right. Okay, so we've got our 1 volt peak to peak, 100 kilohertz square wave. Okay, great. Can we probe this one as well? There we go. We can now probe it. Okay, can we physically get it out though? No, all we're getting out of our physical channel 1 here is the square wave. Okay, because that's what we programmed in here. Okay, so this output 2 is still not working. I'm still getting nothing on that output 2. Yeah, I'm still getting nothing on that output 2. So I don't know how that works. I mean, the whole idea of having this would be that you can add a digital filter and then output the signal. And I've got to be doing something wrong, right? But okay, we can probe these points, okay? And then we can switch that off and on, you know, it's kind of groovy. And then we can choose all our different filters, and we got all of them. Look at this, we've got our Chevs and now elliptics and cascaded and bezels and Gaussian and everything else, right? And then we can adjust that. Let's go down to 100 kilohertz, right? We can tweak that and bingo, there you go. And then we can increase our order here and we get a nicer, smoother sine wave. So let's go to say 200 kilohertz there, right? And then we can adjust our, that's right, that's really groovy, right? From an educational and but if you can't output the signal, what's the point? Well, you can digital filter it and then you can export it, right? You can use all the export stuff, so you can export the data and things like that. That's really good, and that looks like really comprehensive. So yeah, okay, win, but we're internally probing. But what if I want to? I don't understand why it's not output into channel 2 here. I don't get it. So yeah, like it lets me do it. If it doesn't have that capability to do that, then tell me here, like give me an error or so, or just don't let me assign it. And gain, we can like gain that up or whatever, can we? We can view that at that, yeah, so we've gained that up. So we can change that back to, change that to 6 dB and boom, yep, it's jumped up. There we go. So we can adjust our gain and then we can adjust our offset by a volt, can we? Yeah, boom, it's gone off screen. Okay, we can't drag that window. We can make it full screen, but we can't, disappointing that I can't like drag that window and make it bigger. Yeah, going bigger doesn't help us. There's a lot of wasted space here. So what's this symbol over here do? Oh, no, that just goes to there. Oh, okay, we can go full screen on the no, we can't go full, can we go full screen on the waveform? We can't, that's our cursors. No, it looks like we can't go full screen on that. So, I don't know. So we can turn that off in the thingo mode over here. So we can change, like that physically outputs it off there, but we turn it on and it just doesn't, look, it says our output is on, 10 volts peak to peak. Anyway, this video has been probably an hour long already. I'm going to call it quits. I'm like, okay, like I'm pretty disappointed in this. It does some cool stuff, but it like the basics. It's you wouldn't buy this if you just want a US, like a nice flexible, you know, like an upgraded analog discovery USB scope or something like that. No, it doesn't have the oscilloscope input range in it. It just doesn't let you run the multiple instruments except in this multi-instrument mode, which is weird. And then you got to pop up the windows and then it works in different ways. Then if you've got your spectrum analyzer here, you're looks like you're limited to just like sine waves on your generator over here. Like, what's up with that, right? I mean, it's just, no, as flexible as this thing looks and what it probably is with that multi-instrument mode and the buses and stuff, I still haven't figured out that exactly. But yeah, I'm sure it's incredibly flexible for, you know, the research purposes and stuff it's intended for, but for just your everyday practical scope or spectrum analyzer and, you know, just USB instrument, no, I think they've got a lot of work left to do, which is a shame because I liked the hardware. The price point's actually pretty good, but just a bit bummed about the inflexibility of just having all the instruments, just dock them all on the screen at once. Why can't I do that? And then just like play around with things. And it's some things are non-obvious. Looks like there's no user manual for the multi-instrument mode. Maybe there is, but it's not on that webpage that I was on. So yeah, you're going to be buying this if you want like the PID controller and you want the lock-in amplifiers and stuff like that. And you're doing some physics research or something. It's probably great, but no, as an everyday use scope, no, can't recommend it at all, which is a real shame. I wanted to like this, and I kind of do. I like some aspects of the interface, but others just don't work at all, and they're inconsistent. So, yeah, nah, is my verdict for the Moku Go. Probably niche uses and stuff like that, but not as an everyday USB scope and, you know, instrument. No, they've got a bit of work to do, I'm afraid. So anyway, thank you very much, Liquid Instruments, for sending this in. It's cool that it's designed and made in Australia, and they put a lot of work into the software, obviously, but I don't understand a lot of the way that this is Like, I get the concept of the bus thing, and you can put things onto the bus, and then you can mix and match and do multiple, and then you can feed into the bus somewhere else, and then output it at the same time, and do some, some reasonably cool stuff. Yeah, I think they've got to execute a bit better. But anyway, thoughts and comments down below. Sorry this has been a bit long, but yeah, I get carried away, don't I? Anyway, thoughts and comments down below. As always, discuss on the EEVblog forum. Catch you next time.